More folks straggle in. Good afternoon, everyone. Thank you for attending the fifth webinar in the Zero Energy Ready Home series. My name is Jess Hoover, and I am the Climate Action Director for the High Country Conservation Center. This series is sponsored by the Colorado Energy Office and the High Country Conservation Center. HC3, as we're known in shorthand, is a resource conservation nonprofit up in Summit County, and we've been very involved in supporting our community's new sustainable building codes. We provide the energy consulting services listed on this slide to assist local building professionals. And we've been organizing educational workshops like this one to help folks learn what's required by the new codes in our community. We also partnered with the Colorado Energy Office, Energy Smart Colorado, and Deeper Green Consulting to sponsor a local HERS Rater training course so that we've got new HERS Raters ready to support your projects come July 1st when the new codes go into effect in Summit County. In addition to providing trainings like this one, the Colorado Energy Office also created a code adoption toolkit that reviews the cost implications, sorry you all, of changing code cycles, the benefits, and other compliance resources, and more. They are also currently working on a troubleshooting guide that will cover I-code conflicts and alignments, clarifications, and paths of compliance. You can find all of that information on the Energy Office's website and linked on your screen here. Today's webinar will review additional requirements of the Zero Energy Ready Home program. This webinar will be recorded, and the recording will be sent out to all attendees. If there are any issues with audio, please feel free to write in the chat, which can be generated on your screen by hovering over the bottom of your WebEx window and clicking on the chat bubble icon. I have muted everyone's lines to help reduce background noise, but sometimes WebEx does act up. So if you notice yourself unmuted, please feel free to mute on your end as well. That said, we do want to encourage questions, so don't hesitate to use the chat function, and we will answer all questions at the end of the presentation. With that, I will turn it over to our presenter today, who is Robbie Schwarz. Robbie has been a champion of the building science industry for over 20 years. As principal of Build Tank Inc., Robbie works with builders of all sizes to ensure that their high-performance homes are efficient, healthy, and resilient. So thanks again for being with us today, and take it away, Robbie.
Thank you, Jess, and the High Country Conservation Center. I appreciate your support for this. I also wanted to just make sure that we thank the Colorado Energy Office and NORESCO for their support in these series of webinars that we're doing. And then lastly, there are some upcoming trainings that are still scheduled for later this week that you can take part in as well. Today, we're going to be talking about some of the other requirements that aren't specifically in the Energy Star program or the Indoor Air Plus program, but are mandatory requirements of the DOE Zero Energy Ready Home program. So we looked at this graphic before, and we talked a bit about setting the project up early during the design integration meeting side of the equation and making sure that we're getting started early in this process. We talked about optimizing the building shape and orientation a bit and designing a rock solid building thermal envelope so that we're ready to put PV on in the future or potentially at the end of the project as well. We talked about mechanical systems, and today we're going to be talking more about the lighting and appliance requirements. We will be talking a bit about some of the other features that were listed in 1 through 4 as well, because they're noted a little bit uniquely in the DOE Zero Energy Ready Home program. And then we'll be talking about the PV checklist and the renewable ready part of the equation for this program. As we said in the past, the Department of Energy Zero Energy Ready Home program requires that the projects be certified by in both the Energy Star for Homes program and the Indoor Air Plus program. And it's important that we're using the correct versions of these different programs. You can also potentially, if you decide to, utilize Passive House as well. Passive House requires, as a process for certification for that program, use of the DOE Zero Energy Ready Home program. So if you wanted to go kind of a step beyond the DOE Zero Energy Ready portion of the program, Passive House might be a pathway for you to do that as well. Now, the correct versions that we're looking at for this program for DOE, they're still on version 1 of their program, but they are on revision 7 of the program. So you want to make sure you're pulling down the right documents when you're going to their website to pull down those documents. Energy Stars on version 3, revision 10, and the Indoor Air Plus programs on version 1, revision 4. Remember, the revisions really, their objective is to clarify, simplify, and improve the requirements for these different programs so that they're much easier to work with. But it is important to ensure that you're using the right version so you're not getting off track at all with the programs. Now, the DOE Zero Energy Ready Home program really can be boiled down into these 7 core requirements that include the Energy Star program and the Indoor Air Plus program. That's number 1 and number 7. There's some unique envelope requirements that are added to that, some duct system or HVAC system requirements, water efficiency requirements, which is one of the things that we'll be touching on today, indoor lighting and appliance requirements, and renewable ready requirements are the main things that we'll be talking about today, but we will be touching on the envelope as well because there's some Energy Star requirements there that are unique to the program that are a little bit different than we've seen in the past there. The other things that you can do that are encouraged by the program is to take part with the WaterSense label for indoor and outdoor water use and fixtures and irrigation, I guess, for the WaterSense program. The Disaster Resistance program is a fortified home program that you might consider taking a look at. There's a quality management program, and Passive House, as we talked about in the past, is another pathway that utilizes the DOE Zero Energy Ready Home program. They're not mandatory requirements of this program and therefore not mandatory requirements of the Summit County Code, but the program encourages you to take a look at those things as well. So to begin with, just a refresher on what Energy Star is. Energy Star, again, is a program that can be explained by going through this refrigerator example here. So this is just really a refresher here. So in the 1950s, we had relatively small size refrigerators. 9 cubic foot was kind of the average size. And there wasn't a lot of energy used to work that refrigerator. Only about 360 kilowatts per year were used. In 1970s, we began to move out into the suburbs, and we got bigger refrigerators because supermarkets were further away from our homes, and we would go once or twice a week to store that food. We had a 15-foot cubic refrigerator, but really look what happened to the energy use there, 1,700 kilowatts per year. In the 2020 era that we're in now, we're seeing 20 cubic foot plus refrigerators. I've seen as high as 32 cubic feet or maybe even bigger for a residential home. But the energy use is coming back down to a reasonable level here. And really what this example is to demonstrate that the Energy Star program is the reason why the energy use has come back down for these huge refrigerators that we're putting into our homes now. Energy Star's goal, their object, really is one thing, which is to create a specification for how to build an energy efficient product. Now that product can be a refrigerator, it can be a computer, it can be a light bulb, it can be a dishwasher, it can be a variety of different things. But if you follow the specification for how to build that, you'll meet that minimum energy requirement that's deemed to be energy efficient. And they've done the same thing. They've created a specification for how to build an Energy Star house. Now, the reason that we go through this is because Energy Star, as a program for building an Energy Star house, puts out a specification for how to do that. But the specification doesn't necessarily require that you use Energy Star products and components to build that house. However, the DOE Zero Energy Ready Home program does require that you use some Energy Star qualified components to build that DOE Zero Energy Ready Home. And therefore, when you're using this program in Summit County, you will have to install some of these Energy Star components here. Now, again, to be an Energy Star qualified component, whether that's a refrigerator or light bulb or whatnot, that particular manufacturer has to follow the specification that Energy Star has created for that particular appliance or light bulb or whatever other component it is, in order to be able to label that specific product as an Energy Star qualified product. There, it's very similar to what you have to do for a home to be qualified as an Energy Star home. You have to follow the specifications, have verification, and then you can certify that house as an Energy Star for Homes house and label it with the Energy Star label. Now, the rationale here from the DOE perspective is that components and these different miscellaneous electrical loads are increasingly getting larger and larger as we move to using more and more electronics and other smart features in our homes. We are reaching a level where almost 50% of the load in our homes is made up of lighting, appliances, and these miscellaneous loads in our houses there. So the DOE program wants us to gain a little bit better control and predictability of the energy use that's being used by these components so that we can offset them properly when PV is added to the house here. So the program requirement is that you use Energy Star certified appliances. This includes appliances in the categories of refrigerators, dishwashers, and clothes washers. Right now, clothes dryers are not Energy Star certified, but the clothes washer is there. Energy Star certified fans. This would be fans for bathrooms, laundries, and kitchens, as well as your whole house controlled mechanical ventilation fan as well, especially if you decide to use an exhaust or a supply side ventilation system there. Ceiling fans as well would need to be Energy Star certified, and there are a variety of those on the market as well. And then lastly, Energy Star certified lighting needs to be used. And for a minimum in the Energy Star program or the DOE program, 80% of the fixtures or lamps need to be either CFL or LED lights that are qualified with the Energy Star label. Now, this is a little bit interesting because the DOE and the DOE program references the 2015 IECC for the insulation levels that are in our houses as a minimum as well. And the 2015 IECC only requires 75% of the lamps and fixtures be high efficacy lamps and fixtures, whereas the 2018 requires about 90% or 90% of those fixtures there. So the DOE program is landing somewhere in between, which gives you a little bit of flexibility if you're using some brand of fixture where you can't find, they might be using a specialty lighting or light bulb in that particular fixture. But what we're really seeing, especially here on the Front Range, where we've seen a few DOE Zero Energy Ready homes, is that almost 100% of the fixtures now are LED fixtures that are going into these houses. So I expect probably you'll find the same thing is already happening up in Summit County and our mountain regions as well. Now, this requirement, you'll see the little asterisk on this slide, is only a requirement when these fixtures are installed by the builder in the home. So if the builder is not providing a refrigerator or a dishwasher or a clothes washer, for example, then it doesn't have to be installed in that house. If you are offering it as a option for the buyer to buy it and have it installed before the house is completed, then you want to make sure that you're only offering them Energy Star qualified appliances. If that buyer is bringing their own appliances to the house and it's going to be installed after they have the certificate of occupancy, then they can install whatever they want. And it's just encouraged that you educate them and hopefully encourage them to install Energy Star qualified components and appliances in the house there. Now, the Energy Star program talks a bit about the vapor retarder provisions of the code, and that you need to work with those vapor retarder provisions. And we'll be talking our next session a little bit more about that, but I just wanted to bring that up because as I was preparing this slide for footnote 13, footnote 12 came right before it, and wanted to make sure that we remembered that the vapor retarder portions of the code are required, and that the whole water management side of these checklists need to include our vapor retarder provisions as well. Now, footnote 13 talks about the insulation levels of the home there, and that we need to follow the insulation levels at a minimum using the 2015 insulation levels of the International Energy Conservation Code. But this part of the checklist for Energy Star also talks about fenestration, or the window areas and window U values and solar heat gain coefficients. So I wanted to go into that because the DOE Energy Ready Home program varies a little bit from the Energy Star program where this is based out of. Now, remember that windows are our biggest thermal hole in our whole envelope. The performance of that window is significantly less than our wall cavity insulation there. So we want to choose properly that window and potentially minimize those openings so that we have more cavity insulation than window insulation, in essence, in that thermal envelope. From a program requirement, the DOE program says that we need to meet the window product criteria that's listed in the table below. And you'll notice that this table is based off of the Energy Star certification specification for Windows. The most current specification that Energy Star has come out with for Windows is version 6 of their program, which would require a 0.27 U value window be installed in our homes. However, the DOE program is still using version 5, the version 5 specifications, which is the 0.30 U value. And there's some exceptions as well. If you have the right solar heat gain coefficient, you can go slightly above a 0.30 U value window as well there. So I just wanted to again point out the fact that although Energy Star often does not require that you use an Energy Star qualified component in the house, the DOE program does require a number of Energy Star qualified components like the appliances, and in this case, windows. But in this case, they're not using the most recent specification for window creation or construction, I guess I should say. So there are some exemptions or exceptions that you need to think about when you're utilizing Windows. So to get that 0.30 U value, you can use an area weighted average of all the fenestration products that are installed in that house to meet the U value requirement. It also says that the area weighted average of fenestration products that are greater than or equal to 50% glazing shall be permitted to satisfy the solar heat gain requirement. So if you're using a window that is above a 0.30 window, you need to think about that solar heat gain coefficient requirement that was displayed in the table in the previous slide there. Now, 15 square feet of glass can be exempted just by itself. This is primarily for decorative glass that might be used at a entryway to a house, or maybe in some location you might put a stained glass window in the house for some reason, or glass block, or a variety of different reasons you might have 15 square feet of glass that just can't meet that 0.30 requirement, so you can exempt that from the equation here. Also, opaque doors that are primarily glass and hinged on one side can be exempt. You can do one exemption up to 24 square feet of glass area for that type of door assembly. Fenestration utilized as part of passive solar design can be exempt as well. Often, if you're doing truly south-facing glass with the proper overhangs, you want to be able to accept more of that sun's energy into the home than the solar heat gain coefficient that's required by the program would allow. Therefore, you're allowed to exempt that if you're truly doing passive solar design with the right overhangs to protect that glass, especially during the summer months, and allow that energy in during the winter months there. And then if you're using a passive house certification program, they often are requiring and having you use a triple glazed window. A lot of these triple glazed windows are coming from other countries right now, so you might be able to exempt that product as well. But it's also really important to try to understand how that window is performing in the NFRC rating system, because that system is different than the European window rating system, and they don't necessarily correlate right now, and they haven't figured out a way to correlate them. So you will need to figure that out so that you can do the proper modeling for your house as well here. So those are the list of exceptions for the house. And remember that the DOE program does recommend that you consider using a triple pane window, or a window that has significantly better performance than that 0.30 minimum requirement. Triple pane windows are becoming much more affordable. There are a number of manufacturers that manufacture here in the States, so you don't necessarily have to go to a European window. That performance can range from an R value of 5 to 10, which is pretty significantly better than what we're getting with our typical windows out there. They're much more affordable. You do have to think a little bit about if that window is gas filled or not, and taking that window to altitude, and what happens to that gas. Will that gas still be in there? So if that gas is a driver for its increased energy performance, you might want to ensure that you're not paying extra for that gas if you're taking it to altitude, because you're just not sure that it's going to be there as that glass is acclimating to the higher altitude and the pressures at that higher altitude there. Okay, moving forward to duct location. We talked about this a little bit, but it is an additional requirement of the DOE Zero Energy Ready Home program that if you are using any type of ducted HVAC system, that those ducts be located inside the building envelope there. Now, there is an exception. Up to 10 feet of the total duct length is permitted to be outside the building's thermal envelope, and ducts are located in unvented attics regardless of whether the space is conditioned or not. But obviously, if you're building an unconditioned attic or a cathedralized attic situation, you want to make sure that you're ventilating that section correctly with conditioned air, so you're not getting excess moisture up in those areas there. Now, ducts that are located in vented attics needs to follow all of these characteristics, and the dry characteristics are listed here at the bottom. They have to be insulated still. The ducts need to be tighter than normally required by the program, and they need to be tested for both duct leakage to outdoors and total duct leakage. And potentially, you can bury the ductwork in insulation as well if you're doing that as a requirement here. In either case, the HVAC equipment itself needs to be located inside the building envelope. So if you're using a boiler or a furnace or any other type of HVAC equipment to condition that house, it needs to be located inside the building envelope. So you're seeing in some cases where a portion of the duct might be located outside, that they'll locate the furnace itself in a furnace closet on the second floor of the house, but that duct might be outside. It's also a kind of a pathway to bringing that duct inside as you're progressing in that journey to bring all of your mechanicals inside the building envelope. We're seeing a lot of builders take the first step of bringing the actual heating plant into the building envelope and leaving the duct there. And then the second stage would be bringing all the duct down to the bottom core of the truss and be able to mount insulation over that. And then the third phase in that incremental approach would be to bring all the duct inside the building envelope. But again, the DOE program is really basically forcing you to jump all the way to bringing everything into the conditioned envelope, except a very short 10% run or 10-foot run there. The next thing we're going to be talking about is water efficiency. Water efficiency, you basically have two options on how to comply with the water efficiency requirements of the program. The essence of the water efficiency requirement is that you're able to deliver hot water very fast to the occupant so that less of that hot water is being generated and less of it is going down the drain here. So option A begins by saying that less than or equal to 0.5 gallons of water in any piping system between the hot water source and any hot water fixture can be stored by that system there. And it also says that by the time the flow of the furthest faucet away from that hot water generating appliance, whether it's a boiler or a traditional water heater, that you can't lose more than 0.6 gallons down the drain before your temperature of that water rises 10 degrees Fahrenheit. I have another example of this requirement and how it actually gets verified and tested here. So why don't you take a second here and read that so that it makes sense to you. But in essence, you can't lose more than 0.6 gallons down the drain before the temperature of that water increases by 10 degrees Fahrenheit. So you have to design a system to be able to meet that performance criteria there, which in essence means that you can't have more than 0.5 gallons of water inside the piping there. Multifamily buildings, 5 stories or less, have another requirement. So if you're working with any multifamily buildings, this requirement for hot water efficient systems is also a requirement. It's just slightly different than for single family homes or duplexes and townhouses. Now, for hot water distribution systems, you have a variety of choices here, from core plumbing to manifold to demand pumping systems there. And in multifamily, you have some choices as well here, from on-demand systems or storage volume systems here. So when we're talking about hot water distributions, our traditional system, a trunk and branch system, is storing a significant amount of water. So we often start with a 1-inch pipe and then go to 3/4-inch pipe and 1/2-inch pipe distribution systems here. These pipe, if you figure out how much water is actually being stored in the pipe from your hot water heater to the fixture, you see that we have significant amounts of stored volume. So in this case, I have 1.6 gallons of water stored in that system there. And it's going to take anywhere between 1 minute and almost 2 minutes to be able to purge that water out of the system before hot water is actually delivered here. So the goal of this program is to limit the amount of water that's going down the drain to purge the system before you get hot water, and to get hot water in a much faster, more comfortable time range. So if you think about how often or how long you wait for hot water when you wake up and take a shower in the morning, is that time period reasonable or unreasonable for most people? You know, if you're turning on your shower and then going and weighing yourself or brushing your teeth or doing other things before you jump in that shower, it's probably an unreasonable amount of time, and there's a significant amount of waste going on there that the program is trying to avoid. If you're able to turn on your shower and within 1 to 15 seconds be able to get into that shower, that's really where the program is trying to get there. And it gives you a variety of ways to work towards achieving that goal here. The first one is this core plumbing layout scenario here. So thinking about where your wet wall is in your design, your plumbing design, and creating your wet locations, so bathrooms, laundries, and kitchens along that wet wall area there, so that you can limit the core plumbing in the house and the pipe length and the water that's stored in that pipe, so that the delivery of hot water is faster and the wastage of water down the drain before that hot water is delivered is reduced here. So we've got a bathroom or a powder room here in the lower left-hand corner, but that's outside of kind of that core plumbing wall area there, but it's not significantly outside. Now, this is a concept that has actually made itself into the 2021 IECC here, where we see that we're going to be asked in the future here, when the 2021 IECC is publicized and adopted by different jurisdictions, we're going to be asked to determine a surface area that is serviced by hot water systems here, and ultimately diminish the ratio of area that's serviced versus not serviced by that hot water system here, and ultimately change the way that we design our our plumbing systems in order to deliver deliver in a more efficient manner here. So this first example shows a one-story, three-bedroom house that has a ratio of 72. The second one has redesigned things a little bit, and the ratio dropped to 50. And the third one, in the same size house, it's a little different design, they got it down to 5.9% ratio, which is ultimately, that doesn't necessarily mean a lot to us at this particular juncture. But ultimately what it means is that all the plumbing and is so compact and core central to the house that you're able to deliver hot water within 1 to 15 seconds, and very, very little water is going down the drain here. So this is something that the program allows you to use now, and it will be something in the future that we're going to have to think about how to better design our plumbing systems in our houses here. Other ways to work with delivery of our hot water systems are these manifold systems. These manifold systems might look like this in our houses. The idea is that you have one line that's going from this manifold all the way to the farthest fixture, or to each fixture, so that you're reducing elbows and joints in the plumbing line that might create leaky systems in our plumbing systems there. Because the only junction, or the only connection, is at the manifold and at the fixture that the pipe is connected to. However, this doesn't do much for the delivery of hot water and the waste that is created during that delivery system. So there is a 10-foot max rule, which is in essence, I believe, from the water heater to the manifold, and then you still have to be able to meet that performance criteria of being able to deliver from the manifold to that furthest fixture, that zero 0.6 gallons of water with the 10-degree Fahrenheit temperature increase at that moment. It's pretty hard to do with a manifold system, so they give you some other options as well. The next option would be a demand plumbing system. This would be a system that's using a hot water circulation loop there, and some type of pump system and remote controlling device there. So you have a sensor control that would be on demand. So you'd either push that. Ideally, it would be a push button control system there. You push it, and then it would prime the system. And then when you call for hot water, you have hot water instantaneously at that fixture there. You have a demand pump that's pumping. So your remote sensor control is activating the pump to pump hot water to that source, that fixture source, so that you can use it. And then you have a dedicated return line that is bringing water back to the hot water heater there. So it's a closed loop system. They work really well. You just need to, in essence, train the homeowner to use the remote sensor and activate it when they want hot water there. We are seeing a number of tankless hot water heaters that have built-in circulation systems. These built-in circulation systems are allowed in the DOE Zero Energy Ready Home program right now. What they do that's a little bit different is that they work on what's called adaptive learning technology, which means that if I wake up continuously or consistently and take a shower at 6 o'clock every morning, the system will learn that it needs to be primed and ready to go at 6 o'clock every morning. And so when I get to the shower and turn on the hot water will already be there. It works on generally a 7-day cycle. And if you change your behavior, it will continually adapt to your change in behavior. So they're pretty interesting systems. These tankless water heaters do have a small buffer tank inside of it that usually carries about 2 gallons to 2.5 gallons of water, so that you don't get any knocking, you don't get any other issues that could happen with the delivery of that hot water through a circulation loop and a tankless water heater here. So they're good systems to look at. Plus, these tankless water heaters are super efficient in the 0.7 energy factor range. So again, we're seeing a lot of zero energy ready homes use these types of systems here. So just to recap, the following requirements apply to recirculation systems. So if you have a recirculation system, it must be based on an occupant control switch or an occupant sensor if you're using that type of system to be able to deliver that 0.5 gallons of water that we talked about here. Recirculation systems that operate off of this adaptive learning system, that tankless water heater that I just discussed, they are permitted at this time, but there are some questions whether how well they work over time there. So it is something that is continually being assessed by the DOE Zero Energy Ready Home program, and there is a potential that in the future they might not be permitted, but currently they are permitted there. And then recirculated systems based solely on a timer or an occupant sensor are not eligible to be used. So you either have to use the adaptive learning technology or a specific occupant controller or occupant sensor type controller for these types of systems to be able to deliver the water in the way that the program is requiring here. So how do you verify that the system is doing what has been installed to do? again, there's that kind of that question of, is it there and does it actually work? So there is some verification that's being required here. So if we have to verify it, we end up priming the loop, or basically turning the system on. We start the flow and we take the temperature at that flow. We allow 0.6 gallons to be delivered, and we take the temperature of the water after that 0.6 gallons has been delivered, and that temperature increase has to be 10 degrees there. It might not be the full temperature that we want to take a shower in, but we need to make sure that the temperature inside the water pipe has changed and increased by at least 10 degrees after 6.6 gallons of water has been delivered there. So they're efficient, good systems that we want to install to these houses, and is a requirement to be installed in these houses. Okay, so that's option A, is creating a delivery system that can deliver water, that can purge the pipes quickly and efficiently, so we're not losing a lot of water down the drain, and that we're delivering hot water quickly there. So the option B is to work specifically with hot water heating and fixtures in our houses. So there are three things that we need to do in this case. First, we need to have an efficient hot water heater. So for a gas hot water heater, you have to have an energy factor of 0.9 or a UEF, which is a unified energy factor of 0.87, or an electric water heater that is very efficient as well here. Now, there has been a change in the way that the energy efficiency of a water heater is assessed. So I just wanted to go over that real quick here. The water heater basically is the same as it always is. It's just the way that that water heater's efficiency is being assessed is different. For the energy factor, they're using old requirements to evaluate efficiency. For the uniform energy factor, they're using these new DOE requirements to evaluate the efficiency. The energy efficient modeling was interpreted differently for different appliances, and the new uniform energy factor creates consistency in that modeling methodology there. The higher the number, the more efficient the system is, and that's true with both scales. Either way, you're looking at both scales. So this is a quote that came from just some research with regards to just highlighting the inconsistency and the unreliability of the energy factor measurement and modeling, and therefore they moved to the uniform energy factor. And Ream, for example, is saying that the new standards is more accurately reflecting real-world usage and should help consumers make a better apples-to-apples comparison of the different brands that are out there. So when you look at an energy guide label, there are a couple things that the new uniform energy factor is trying to do. First, it clearly displays the storage capacity of the water heater that you're looking at. It also talks about the first hour rating. And this is something that the normal energy factor modeling didn't do well, is that it breaks out these different categories from very small, low, medium to high. And it gives you the ability to, in this case, look at the high volume water heater and its first hour rating, and you can compare that to other high volume water heaters out there or other low volume water heaters out there. And it turns out that their efficiencies change pretty dramatically based off of the size of that water heater. And that's something that the normal energy factor, the old energy factor guide, did not take into account. So this is one of the bigger things. And the way that we get that apples to apples comparison is being able to compare size water heaters to the specific size water heater that we're comparing to. And then lastly, we get this estimated yearly energy cost for the water heaters there in the specific size ranges that we're talking about. And again, giving us that ability to compare as an apples to apples comparison. And then they give other data here. Really, what's missing, unfortunately, with the energy guide here is the actual uniformed energy factor number that is associated with that particular water heater. So you have to go to other resources in order to get that number and make sure that it meets the requirement for this option B, as in terms of an efficient hot water heater that's being installed inside of that home. Okay, so the next thing you need to do with option B is you need to install WaterSense labeled shower heads at bathroom sinks and faucets there. And also consider efficient, if you're going this route, you should also consider WaterSense labeled toilets as well. But because the toilets don't have that additional energy component, it's not a requirement of the program here. But it does give you additional marketing message that everything in my house is WaterSense labeled and verified there. And you can take advantage of that without actually doing the majority or the rest of the WaterSense program if you don't want to deal with the outdoor water usage components of the program as well. But you do need to, for this option B, you do need to have shower heads that are WaterSense labeled and all faucets, bathrooms, it should be kitchens as well, that are WaterSense labeled fixtures there. And then lastly, the storage volume inside of the plumbing system or from the pipes that are running from the water heater to that farthest fixture have to be able to store less than or equal to 1.2 gallons of water. So you have to figure out the diameter of the pipe and the storage volume of that pipe per foot of pipe that's being installed, and basically design a system that can't store more than 1.2 gallons of water here. So although there are two options here, we're seeing that the majority are choosing option B to install a hot water circulation system. We just don't have tons of experience at designing plumbing systems that only store 1.2 gallons of water. And I think that's the main reason why we're seeing option A used most often. The reality also is that you should be considering a combination of option A and option B, especially using the high efficiency water heaters. You're going to need that to be able to maximize your mechanical systems before it makes sense to put on PV on those houses, which is the last thing that we're going to be talking about today, which is the PV Ready checklist. The PV Ready checklist has been created because we're seeing that we're seeing basically that the cost of PV is coming down significantly here, and more systems are being installed. And even if you're not going to install it at start, we have to be ready to install that PV system to get to that zero energy ready home, or that zero energy home here. So the electricity requirements, the solar electricity requirements here, are to document the roof load of the house, that the house and the framing trusses or framing members can carry the weight of the panels that are going to be installed or installed in the future, to create a conduit from the roof to wherever the inverter is going to be located, and to have a dedicated area for installing that inverter system in the home, have a conduit from the inverter to the electrical panel, and then have space in that electrical panel that can receive a 70 amp circuit. Now, these requirements come from another guide or checklist that's not a mandatory checklist of this program. It's a more holistic solar voltaic specification and checklist guide. You can get this guide here. It goes further than where the DOE's checklist goes. but the DOE's checklist is based off of requirements that come from this checklist that's shown on this slide. Now, the Renewable Ready says that it's not required for every home. So if any of the three conditions below is not met, the home is exempt from the requirements contained in the PV Ready checklist. So in essence, you're not mandated to utilize this PV Ready checklist. But even if these things aren't mandated, it's recommended that you use the PV Ready checklist and the house be made ready to add PV, because we're seeing that a significant amount of energy can be generated even from not ideal orientation. So the first thing that says here is that your location, based on the zip code, has to be in the proper location to get enough sun, to have access to enough sun to be able to generate at least 5 kilowatts of average daily solar radiation in that house there. So I'll show you a map where you can get that information. The second requirement is that the location does not have significant natural shading. So if you have trees or tall buildings or other things that are significantly shading the roof area that you're working with, then you're not necessarily required to do the DOE Zero Energy Ready, Renewable Ready checklist here. And then homes as designed has adequate free roof area that's within plus or minus 45 degrees of true south. So if you don't have adequate free roof area, again, you're not required to do the Renewable Ready checklist here. Okay, so this is that number one part of the checklist, that you're looking for the daily solar radiation per month. This map is available online. You're looking for that light yellow area that's kind of bound by the blue lines here. Those are areas that are generating enough kilowatts per meter per day in order to qualify for mandatorily requiring the PV Ready checklist be implemented on that house here. Again, if it's not generating that 5 kilowatts per square meter per day, then it's encouraged that you use the PV Ready checklist. The second item on the PV Ready checklist is the significant solar resources that are accessible. So again, if you have trading, tall buildings, you don't have enough roof area, then you're not required to do the PV Ready checklist. It's encouraged to do that. And then there's multifamily requirement as well here. Adequate roof area is based off of the size, the conditioned floor area, and then the roof area here. So you can go to this section of the PV Ready checklist and the DOE program documents to get this table here and to make your evaluation of if you should put PV on or not. The PV Ready checklist asks you to designate a proposed array location on your plan set so that you can implement that later if you're not going to install PV right now. And I guess I should say that up front, if you're already installing PV, you don't need to do the PV Ready checklist as an additional documentation. You just need to carry out the items that are in the checklist correctly in that house. You also need to provide the right orientation and azimuth on the checklist so that you can document that. You need to be able to document the correct tilt of the panels so that you're getting maximum generation of photovoltaic electric energy from that system. You need to provide code-compliant documents that says that the allowable dead load and live load ratings of that roof can handle the additional weight of the PV system that would be installed on that roof. That should be on your plan set and document as well. The PV checklist goes and says that you need to provide architectural drawings of the PV system and its components, listing these things that are here. Alternatively, you can provide a home buyer with the following information, but the easiest way to do that is on a plan set type document. requires a 1-inch metal conduit that you can run a DCA wire from your array to your inverter location. Now we see a lot of other tubing being run from attics to basements, for example. Those tubes generally are designed to run low voltage wiring or other wiring that, so you just really need to make sure you're using the right kind of conduit that can handle code compliant DC wire from your panels to your inverter here. And then you need to be able to document that you have the right metal conduit that runs from the inverter to your electrical panel itself. And then lastly, have an area designated where you can put a 4x4 plywood panel or this alternative blocking so that there's a place designated to house the inverter panel in your home. And then you have to have enough space in your circuit breaker box to be able to handle a minimum a 70 amp circuit so that you can tie that PV system that might be added later in the process into the electric panel itself here. Now, if you're looking for a source to better help design your PV system, there is this PV watt calculator software. That's a software generated by NREL, and you can go to this website and get that as well. Okay, so I think we have completed these additional requirements here. So to conclude again, remember to start early in this process, utilize that design integration meeting to talk about PV, Windows, talk about these other mandatory features in there. Are you going to supply appliances or are you going to let the occupant do all that afterwards? What are you going to do and what you aren't going to do? And how are you going to integrate these requirements into your normal construction process here? You need to think about the DOE Zero Energy Ready requirements and how they add to the Energy Star requirements that are mandatory and the Indoor Air Plus requirements that are mandatory. You need to think about what's a recommendation versus a requirement and if you're going to follow those recommendations. And you need to look at all the footnotes for these three programs, the DOE program, the Energy Star program, and the Indoor Air Plus program, because the footnotes house a significant number of requirements that go beyond just the checklist item that you might be looking for in the field there. And then in order to meet that DOE Zero Energy Ready promise, which is the promise that your house will be ready to put PV on to take it to zero sometime in the future, you need to make that choice as well so that you can decide, are you promising this something in the future or are you going to put PV on the house now in order to go to zero right now? And then ultimately, in Summit County, we have to figure out how this all integrates into code. And again, that means starting early in this process to be able to integrate all these things that are now a code requirement starting in July here. So thanks so much for taking time today. We have one more session that's going to take place on Thursday. I look forward to seeing you then. But if you have any questions, I'm happy to hang out and chat a little bit, or you're more than welcome to send me an email or give me a call as well.
Great. Thank you, Robbie, for that excellent presentation. As Robbie mentioned, we welcome your questions and we are both happy to hang out on the line. If you have any, please feel free to either unmute yourself if you have a question, or you're welcome to use the chat box as well. All right, I'm starting to see folks logging off and not hearing any questions or seeing anything in the chat box. I'm going to stop our recording.